This video goes over the notes from Objective 4.1 video part 2. Let's start with a little rule that we're going to use while simplifying in this section. Take a look at the square root of 5 times the square root of 5. Recall from video part 1 that when you're multiplying two radicals, we can multiply their radicands. So the square root of 5 times the square root of 5 would become the square root of 25, which we know is 5. Square root of 7 times the square root of 7, 7 times 7 is 49. Square root of 49 is 7. Let's take a look at this and look for a pattern. So the square root of 5 times the square root of 5 was 5. Remember, when you multiply something by itself, you're squaring it. So in this case, we are squaring a square root. Notice how those operations undo each other. So what do you think the square root of 346 times the square root of 346 is going to be? Well, you can do it the long way and multiply 346 times 346, which would be the square root of 119,716. Or you can just see that the square roots are going to undo each other, and you're going to end up with 346. Now, we're going to use this to do our next part. So when simplifying fractions containing radicals, we do not want the denominator, so remember denominator is the bottom of a fraction, to contain any radicals. To get rid of a radical in the denominator, we do what's called rationalizing the denominator. In order to rationalize the denominator, we need a property called the quotient property of square roots, which says that the square root of 2 over 5 is the same as the square root of 2 over the square root of 5. Whenever you are faced with a problem with the radical in the denominator, first see if you can simplify that radical. So for instance, on A, the square root of 16 is 4. So I can start by rewriting this as 5 over 4. So instead of having a radical in the denominator, we just have an integer. So 5 over 4 would be our final answer. So take a look at example B. Square root of 3 over square root of 10. We cannot simplify the square root of 10 like we could on example A. So this is where rationalizing the denominator comes in. We are going to multiply the top and the bottom by the radical in the denominator. So on top and bottom, we're going to multiply by the square root of 10. Square root of 3 times the square root of 10 is the square root of 30. Now remember from our earlier example, on bottom, the square root of 10 times the square root of 10 is just 10. Now some people would be led to think that they could simplify 30 over 10 in this case. But just like with multiplying, we could only multiply the things that were on the inside with the things that were on the inside. It's the same way with dividing. We cannot simplify the square root of 30 over 10 because one of these numbers is a radicand and one of them is not. Check your radicand 30 and see if it's divisible by any perfect squares. In this case, it's not. So since our radicand is not divisible by any perfect squares, and we no longer have a square root in the denominator, this is our final answer. Let's do this process again to make sure we get it. So in this one, we're going to start slightly different. Since we're starting with a fraction within a radical, we're going to start by splitting up the square root of 2 over 3 to the square root of 2 over the square root of 3. We're going to multiply on top and bottom by the square root of 3 since we can't simplify it. And when you're multiplying fractions, you want to multiply across the top. So the square root of 2 times the square root of 3 would be the square root of 6. And across the bottom, square root of 3 times the square root of 3 is just 3. Then check to see, can you simplify your radicand? 6 is not divisible by any perfect square, so we cannot simplify it. Since 6 is a radicand and 3 is not, we cannot simplify them together. So this is as far as we can take our answer. The radicand is not divisible by a perfect square, and there's no radical in the denominator, so we're done. Let's take a look at example D. There's a couple of different ways you can approach this one. First thing that I notice is that the square root of 8 can be simplified because 8 is divisible by 4. So we can either do that now or we can do it later. I'm going to go ahead and take care of it now. So the square root of 8 can be rewritten as the square root of 4 times the square root of 2. So I'm going to go ahead and rewrite this as 3 over 2 root 2. You could have done this last, so either way is fine. Now I'm going to undo that root 2 in the denominator and multiplying on top and bottom by the square root of 2. Now when you do that, on top, 3 times the square root of 2 is just 3 root 2. Since one of them is inside a radical and one of them's not, you can't actually multiply 3 times 2, so we just leave them separate. On bottom, we have 2 times root 2 times root 2, which is 2. So we have this 2 on the outside, and we get the 2 from multiplying these two guys together. So 3 root 2, and 2 times 2 is 4. And then we check to see, can we simplify? This radical, 2, is not divisible by any perfect square, so we're done there. There's not a radical in our denominator, so we check the numbers on the outside. The fraction 3 over 4 cannot be simplified, so we are done. 3 root 2 over 4 is our answer. Now, just to clarify, this is not an example on your page, but I'm going to talk about it anyway. Let's say you had 4 root 2 over 8. Let's say this was your final answer. You cannot simplify the square root of 2 and there's no radical in our denominator. So I'm going to check 4 over 8 and see if I can simplify it. 4 over 8 simplifies to 1/2. So I could simplify this to 1 root 2 over 2 or just root 2 over 2. So always check your outside numbers and see if they can be simplified just like you would simplify a normal fraction. Alright, let's take a look at E. I have the square root of 7 in the denominator. So I'm going to multiply by the square root of 7 on top and bottom. Once again, on top, we can only multiply the things that are both in radicals. So the 3 is going to stay on the outside, and 5 times 7 is going to give me 35 as my radicand. Square root of 7 times the square root of 7 is just 7. I look at my radicand 35 and see that it is not divisible by any perfect square. There's no radical in my denominator, and 3 over 7 does not reduce, so this is going to be my final answer. Let's take a look at F. Remember, we always want to check to see can we simplify our radicals. Well, square root of 9 is just 3, so I'm going to start by doing 3 over 3. I immediately see that that simplifies to 1, so that turned out to be a pretty easy problem.